This video will show you how to create an on-premises system. To do this, we start from an example in which a topographic survey has been carried out using RTK using a reference base with coordinates on the fly. For this reason, it is observed that there is a certain displacement between the data taken in the satellite map. The red lines do not coincide with the end of the pavement. To correct this, a local system is going to be created, in which 3 points with known coordinates are going to be matched with their counterparts measured in the field. To do this, Menu, Local System, Create. The window on the left shows the measured data, which we will call the source coordinates, and on the right the data with known coordinates, which we call the destination. Clicking on the Destination Coordinates button and the file of known coordinates with which you want to adjust is loaded. Once loaded, we identify one by one the different homologous points that are going to be used. This process can be done in 4 different ways. The first and simplest would be for the case in which the points of origin and destination were named the same. In this situation, the pairing is automatically set for all points with the same name and they are included directly in the transformation. As this is not the case, it shows how to do it manually, by means of a graphic designation or list of points. The window on the left looks for the first point of origin, base 501, graphically and clicks on it. Next, the homologous point in the right-hand window, point 8001, is also designated. With this, the program establishes a displacement transformation with a single point. We go to the adjustment window, and TcpGPS allows you to apply 2 transformations, translation in 2D or 3D, having only one point. The residuals are 0. We go back to the previous window to match a second point. In this case, we graphically search for the BR502 stakeout base and select it. On this occasion, the pairing is made by pressing the Edit button to search for the counterpart directly from the lead. Saint of destination points, the Destination Coordinates button is pressed and point 8002 of the list is indicated. OK, horizontal and vertical adjustment is applied. And as you can see, the mean square error is updated. Always once paired, the points involved in the transformation are shown in green on the destination screen. The new transformation is verified and the 2 pairings are observed, and a 2D Helmert transformation is used for a better fit that allows the rotation in addition to the displacement. We go back to make the third match. In this case, we are going to select the points from the list instead of making graphic selections. This window allows you to directly measure the point to be paired with the GNSS button and displays the measured coordinates of origin. Then the counterpart point of the destination list, 8003, is searched for and accepted. As we have said, in this window it is possible to measure the origin point with the GNSS button or select it from the list of measured points, in this case the last point that was taken during the survey, the BR503. We move the window upwards, verify that both the horizontal and vertical windows are active, and adds to the setting. As you can see, the mean square error changes. Since there are already 3 points, it is possible to make Helmert 3D in the adjustment window. If you wish, you can change the transformation, enable, deactivate points, horizontal, vertical adjustment, etc. Once the result is validated, it is accepted and given a name. After that, the application asks if you want to apply the transformation to the current project and that only points will be transformed, allowing it to be applied only to the measured points, by default, or if desired, to all the points of the project. After accepting it, it is verified that the break lines now coincide with the satellite image. Likewise, in the project information you can verify the transformation that is currently being applied and see its parameters, such as the type of transformation, Helmert 3D, name, translation and rotation by each axis and the values of the scale. In Export, it is allowed to generate the NTR file, to apply it if necessary in other similar projects.